Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is the DP examination that was written on the 25th of May 2023. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP examinations and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Our first question goes thus. A cylinder with closed ends has an internal diameter of 100 millimeters. So our small diameter is 0,1 and a wall thickness of 50 millimeters. Now what we need to realize is that from here to here is 100. And from here all the way around is 50. So to make a diameter, and that's 50 as well. So to make a diameter, it goes from end to end. Now when you go end to end, 50 plus 100 plus 50, that is 200. So the diameter on the outside is 0,2. So the cylinder is simultaneously subjected to an internal pressure. So pressure internal is equal to 100 megapascals times 10 to the 6, because that is how you'll be using it. And an external pressure of 40 megapascals. So the outside pressure, now our pressure on the outside is 40 times 10 to the 6, because that is how you'll be using it. And Young's modulus, which is E, is 200 times 10 to the 9. And Poisson's ratio is 0,3. So, first things first. Now we need to know what questions they're going to ask. Calculate the resultant hoop stress at both diameters. So, what we're going to do is use this formula over here. We want to get to a stage where we can use this formula. We're going to use this one first, then we're going to use this formula. I'll show you how we do it. So, first things first is R at 0,1 equals A plus B over 0,1 squared. Now delta R is equal to, and 0,1 is equal to 100 times 10 to the 6 equals A plus 100 B. That's how this one works. So this is equation 1. Now we're going to use equation 2. So the radial stress at 0,2 equals A plus B over 0,2 squared. Now, what we're going to do, the radial stress there is 40. 40 times 10 to the 6 equals A plus 25B. And that is 2. Now, as we remember our simultaneous equations, if you'll remember simultaneous equations from mathematics, we will go 100 times 10 to the 6, so 1 minus 2. So equals A plus 100B. Now, this will equal 40 times 10 to the 6 equals A plus 25B. So, now this is 1 minus 2. So we replace everything with a minus. Minus, minus, and that becomes a minus. And that becomes a minus. So our answer will be 60 times 10 to the 6 equals 75B. And what we need is the answer here. So this is 60 times 10 to the 6 all over 75 equals B. And I think this is 800. 60 times 10 to the 6 over 75. Is 800 times 10 to the 3. So B equals 800 times 10 to the 3 pascals. Well, it's just a number. In this case, it's just a number. It's not in pascals, it's not in anything. Okay, so what we need to do is get, I would use equation 1 in this section for now. I would use equation 1. So, to get A, 100 times 10 to the 6 equals A plus 100 times 800 times 10 to the 3. Okay, so we want A. So all we have to do is say 100 times 10 to the 6 minus 100 times 800 times 10 to the 3. So all that has to happen now is 100 times 10 to the 6 minus 100 times A, and A equals A. A equals 20 times 10 to the 6. Okay, so we've worked out the first part. We basically worked out the first part of the question. So now we're going to deal with a hoop stress. We just needed A and B. Then we put them in and then we work out the resultant hoop stress. So that was question 1. Now we're moving on to question 1.2. This is how it's structured in the test. No, wait, it's still 1.1, sorry. Still 1.1. So what we're going to do now is, say, our hoop stress. So hoop A minus B over D squared. Okay, so our hoop at 0,1 equals 20 times 10 to the 6 minus B 800 times 10 to the 3 over 0,1 squared. So all we have to do is say 20 times 10 to the 6 minus 800 times 10 to the 3 over 0,1 squared. And this hoop stress equals minus 60 times 10 to the 6 pascals, which is, now they'll always want you to tell them this is a tensile. That's a tensile load, because it is pushing out. This is due to internal pressure, so it's pushing out. Now, H at 0,2 equals 20 times 10 to the 6 minus 800 times 10 to the 3 over 0,2 squared. Now, this will equal, you put this in your calculator, and you get 0 times 10 to the 6 pascals. Now, these will be important later. So this is hoop stress at 0,1 is negative 60 times 10 to the 6. Hoop stress at 0,2 equals 0 times 10 to the 6. Because when we're going to go for 1,2, they're going to ask for, they're asking for the resultant internal diameter. So how that works is quite a little piece of mathematics. So 1,2, the internal diameter, that's 0.1. So D1 equals D over E times hoop stress minus rho times radial stress. Okay, now what we're going to do is do the internal diameter. So this equals D, which will be 0,1 over 200 times 10 to the 9 times the hoop stress at 0,1 is minus 60 times 10 to the 6 minus, that is 0,3, and this is multiplied by 0,1 is outside, so that is 100 times 10 to the 6. Okay, let's do our calculation quickly. 0,1 over, this equals minus 45 times 10 to the minus 6 meters. Now we're going to do this. Now 1,3 is they want the external diameter. So we do exactly the same formula. So that'll be 0,2 over 200 times 10 to the 9 times 0 times 10 to the 6 minus 0,3 times 40 times 10 to the 6. And this equals, and this particular one equals minus 12 times 10 to the minus 6 meters. Okay, so our D1 is negative 45 times 10 to the 6, negative 6, and D2 negative 12 times 10 to the minus 6. Now both of these are actually an increase. Both of these are actually an increase. They will increase in size. This diameter will increase, especially with the pressure on the inside, and the width, the thickness will shrink. So let's take it as now they want both. They want the resultant external diameter and the resultant. Now these aren't the real diameters, these are just answers to get, and then all we do is turn them into millimeters. So what I'm going to do is 1,2, this is going to go 0,045 times 10 to the minus 3 plus. So this is going to be 100. Yes, 100 millimeters. So this equals 100,045 millimeters. 1,3 is going to equal 0,012 times 10 to the minus 3 plus 200 millimeters, which equals 200,012 millimeters. So resultant diameter 1 is 100,045 millimeters. Radial diameter of 2 is 200,012 millimeters. So now at question 1,4, they want the resultant thickness. They want the resultant thickness of our now they want the resultant thickness. So that is D minus D over 2. So that equals thickness equals 200,012 minus 100,045 divided by 2. Our answer for the resultant thickness is 49,984 millimeters. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.